Ben,
Yeah.
what are you doing?
Oh, I'm some art.
You forgot the unicorn.
I don't know how to draw a unicorn. You'd have to draw the unicorn for me.
I don't think I really want to draw a unicorn. I'm not in that mood today. So why are you so cheerful?
Because I love JavaScript. I just love this language. For the last couple months we've been doing these videos, and I've really come to an appreciation of the awesomeness that is the language JavaScript.
What parts did you like?
Oh, there's a list of things.
Okay.
One of my favorites recently, I've been doing a lot of research on functional programming.
Okay.
And I really just love that JavaScript is a functional programming language.
Could you show me what you mean? I don't.
Yeah, because we did stuff. Functions in JavaScript are first-class citizens. They're sometimes called higher-order functions, and that means functions can be values. So var me equals a function, and do whatever in there, and then you can pass this as a parameter to another function or whatever, and you can, they're first class citizens. And
so just because you can declare the function as a variable, you think that it's a functional language?
it is a functional language because you can define the functions and pass them around, and
But that's not functional programming.
sure it is.
Well, functional programming in its purest sense is you have input. So like say, let me see the marker now, we can switch spots. In my understanding of functional programming, it means you basically have a function that takes parameters. So let's just say, we'll just do a function signature here to keep it simple. You take in A and B, and you get out C, and nothing inside of this function can be messed with.
So,
the only state that it has is A and B passed into it.
If I put 4 and 5 in here, I always get 9 out.
Let's see, are we adding?
If we're adding these things.
Yes, if we're adding, then yes, then you'd always get 9 out. You
So,
would never have side effects.
I can do that with JavaScript.
Well, sure you can, but it's not enforced. That you can have some. You can, for example, let's say you inside that function. You can just put some kind of willy-nilly z in the middle of the function, and it would assume that you meant to do that. And it's going to assign it to global scope, and then, well, if you assigned it anyways, if you said z is equal to 0, right, then it actually came out here and put it to the global scope, and then some other function could say, hey, I want z too, and they mess with z, and they got 0.
So you're telling me that in a real functional programming language, these are all boxed up and self-contained, and nothing can get in or out?
Yes, you would
Except
make
by the
Haskell
interface?
programmers cry if they had to write in JavaScript, because it'd be like there are side effects. And these side effects, matter of fact, they toiled and toiled over how to handle this one function, you know? Like, oh no.
Oh, I remember reading about this, because you theoretically you should be able to call this today, tomorrow, or any day, and it should always have the same output, right?
Right. But the problem is it comes back in milliseconds or however they do that. I can't remember what the command is, but you know, that's problematic. Because now this is, every time you call that, it's changing, so there's side effects. So what they do is they end up rolling it up into something called a monad, so that you know that, hey, this is a side effect deal, and it changes.
So JavaScript isn't a functional programming language.
JavaScript can be a functional programming language, but it's not a pure functional programming language.
Fine, right out on my parade.
Okay.
I've got a list.
Okay, well let's hear some more. What else what are the unicorns in Ben's land?
The other reason I love JavaScript is because it is so darn object-oriented, like way down to the core.
Okay, well, example please.
Everything is an object, right? I can say var num equals 12, right?
Well,
And then,
yeah.
just wait.
Okay, I'm waiting.
I can
I'm
say
just wondering what you're trying to do.
12, I gotta wrap this up, dot toString, and call functions on that 12. That means it's an object, right?
Well, not exactly. What happens here is when this is actually what they call a value type, and this value type actually gets wrapped. It's not a reference type.
So it's not, 12 isn't an object?
No, 12 is actually a primitive, as we would call it in other languages, and what happens between here and here is it gets wrapped in a wrapper, and go read ECMAScript specs, it's horrendous. It's called getValue.
Okay, so maybe it isn't purely object-oriented, but it still acts like an object-oriented language. Like, I have the new keyword, right? I can define types
Okay.
and use
So how would you
like,
define a type? I'm a little bit. Are you talking about classical inheritance, or are you
car
talking about?
equals function. And I granted, this way of defining a type is a little weird. I don't think anyone's gonna argue with that.
Okay, so.
And then do whatever and say var c equals new car.
Okay, so you use the new keyword and it looks just like classical inheritance. Is that what you're saying?
This is straight out of C land.
Well, what if you forget the new keyword?
You get whatever result is there, I guess.
But then you don't, because actually the scope of this in here would be equal to the window in a browser, or some global scope in server-side JavaScript. So it may be perceived as a classical inheritance, but or classical object-oriented programming, but in all reality, it's not that.
Why are you making stuff so complicated?
Well, then how do you even do inheritance in this mess? I don't.
Well, you can do inheritance, but you can't do it this way.
Okay.
Everybody knows that JavaScript is a prototypally inherited language.
Okay, well, enlighten me.
Okay, so I've got my car.
Okay.
Now, if I want all my cars to have something in common, then I'll say car. That's a big C to match function up here. Prototype dot speed equals 55. Now all of my cars have a speed. I just inherited.
So your cars start off right out of the assembly line, 55 miles per hour.
That's the kind of guy I am.
Right out of the gate.
We don't sit around.
Oh wow! Yeah, okay, that's good.
There's some inheritance for you. Good prototypal inheritance, which, by the way, is awesome.
So this is wonky. So you're saying, you can write this, but most people are used to classical inheritance, things being described inside the class. This is like monkey patch nightmare.
Well, most people are wrong.
Okay, well, I'm just saying.
Plus, with prototypal inheritance, you get the prototype chain.
Okay. Well,
so, I'll give you that one. It's a little weird to be doing stuff outside the type definition.
It's like dangling. I won't use Douglas Crockford's example, but you can use your imagination.
See, there's more than one kind of car out there, right?
Okay.
So I can have a car.
Okay.
And I drive a Ford. And you seem to have an obsession with Mazdas.
Well, that was the first car I ever bought with my own money, so, I sold a painting and bought the car. Okay, it's actually, I think, my wife's money, but,
You should draw us a unicorn. And then mine is a Focus. I'm not sure I should admit to that.
Yeah, this is
on
bad.
YouTube. It's one of the newer ones, not...
He drives the Ford Focus.
See this prototype chain here? Isn't that beautiful? So I could say a car has wheels up here, and then my Focus and your protege, they're all gonna have 4 wheels, right?
Focus.
You can't accent
do
the
consonant. Sorry, I messed that one up bad.
It's gonna have to be Focus. Take note, Ford. I want credit.
Okay.
I'm stepping off the screen.
So I don't. You're thinking this is inheritance, but. So you're thinking that if you do what? If you did some kind of let's use our imagination here. So we had a car and it's equal to, we better do the var or we'll be yelled at for weeks. Write a function. That's the constructor. ... Right?
Yeah.
And then you want to inherit that. So we're working for let's do the Mazda now. But we first need an instance of the car, right? Or if you want to use prototype inheritance, C. So we have C is equal to a new car. Well, that's
textbook prototype.
Okay,
right here.
so then what you're going to say is you want to add we'll add a Mazda, and that's equal to a function. So I'm going to like that up there,
Yeah.
and then I'm going to add another one. We're going to say Mazda. So sorry.
Oh, you got to hook up your prototype.
Sorry, forgot about that puzzle.
Prototypal inheritance.
Okay, so Mazda dot prototype. They could have shortened that word too. Dot, no, not dot, equals
C.
The C. So there's your prototype chain, right?
Yeah. So I can walk from here to there.
Okay, so now let's say that you're right. This prototype fairy dust works.
You seem to think I'm not.
I don't think you're right, because I think if you said var m is equal to a new Mazda, right? That should be a car, right? Well, it is. So if you say instance, right? You're going to use an instance of, I'll get this out of the way. So if you said m is an instance of car, what are you going to get back?
True.
Okay, so we know this instance of a car. But let's find out what the constructor is of that Mazda. So you say m.
It's obviously Mazda because I said new Mazda.
But here's the thing. It's broken. Because they tried to make it look like, classical inheritance. I don't know what they did, but it's not working. Because if you say m.constructor, what are you going to get? You said Mazda. Car. It doesn't matter how far down you go. Even if you're down here at this level, you say protege.constructor. Guess what it's going to say? Car.
So you're telling me my all great and powerful prototype chain doesn't even exist?
It's like broken. And if you want it, you've got to maintain it. So I guess, maybe we can say that this works. But if you want it to work, you better maintain it yourself.
Boy, are you some kind of JavaScript hater?
Well,
Do you hate this language?
No, I'm not saying. I'm just saying that if you want it, see, all you have to do is say Mazda. I'm not saying I hate it. I'm just saying you got to know. Prototype. Well, I was about to say protege. Prototype dot constructor equals Mazda. So you have to do a little bit of babysitting.
I took that on myself.
You do. Well, so now you have this dangling weird thing after you declare the darn thing, and you have to make sure you do it after you sign it to the car instance, because now that's confusing. Because if you actually take that car instance and ask what its constructor is, well, anyway, so it's just all a nightmare.
I changed my mind. I hate JavaScript.
Well,
JavaScript is the worst programming language ever written, and don't even get me started on the date type or the type of operator, because that stuff is just worthless.
I didn't say it was. I didn't say
No,
the language.
you did.
No,
You said that JavaScript is a horrible language, and we
No.
should never ever write JavaScript again.
I'm just saying it's broken.
So,
In parts.
so you like it?
Well, here's why I like it. I told a friend a long time ago that the reason why I like JavaScript is because I can make it do anything I want. If I want it to act functional, I can enforce that. If I want it to act classical inheritance, OOP, I can enforce that. And even if I wanted to make some kind of strictly typed system inside of JavaScript, I'm sure I could do it. Used object mirrors or something. But the fact is, I can mold JavaScript into anything I want. And I remember hearing once that, I think it was Eric Myers, an interview with Eric Myers, that somewhere in a language, the people that are creating the language want an escape hatch.
Okay.
And it always surfaces with the casting. So you'll see I don't know, it's a type object, and then they'll downcast and upcast.
So in a statically typed language, or in a strictly typed language,
Yes.
you always see this cast operator.
Right.
And that's because strict typing doesn't always work.
Right. It's just because with that strict typing, there comes times where you can't strictly type enough. And if you do, it becomes really a hindrance on the developer. So, for example, you can't even type lambdas for in C#. What's it called? Delegates. There's only so much typing they want to do, and Simula, I think, is the language that's like crazy. And there's only so much that you can describe.
So strict typing falls apart, but JavaScript saves you from that.
Well,
And
yes.
and functional programming, you mentioned a problem with Haskell.
Right.
So functional programming has limits, but JavaScript saves you from that.
Well, yeah.
By being both imperative and, we should make a list.
Yeah, well, let's draw a circle. And a list, I guess.
JavaScript
What can it resemble, I guess, huh?
is imperative.
Yes, you can make it imperative. If you want to. You can mold it to imperative.
It's functional.
Yeah. First class functions. You can also use functional style programming by passing.
It's dynamic.
Yep.
We already know I can't do math. Hopefully I can spell.
Okay, so it is dynamic.
And you telling me I can make it strict if I want it.
Well, the reality is this. It's like, I think you said this earlier, it's like the Wild West. It's, the reason why JavaScript is so easy is because there are no rules. And the rules that are there, they're broken. I mean, you try to use type-ups for a few minutes and you're going to scream at it. Because you find out that type-of null equals an object. And you say, what in the world? So the reality is this Wild Wild West is there, and it seems like it's there to hurt you.
So are there any, did we miss any paradigms in here?
I don't know. Like working language, I'm not quite sure. But to me...
Boy, it looks like we've got everything.
Well,
these things you have to do a little extra work.
yeah, I mean, well, what happens is you build an infrastructure, right? I remember when I first started working with EXTJS, they built a whole infrastructure for their imperative style programming of classical inheritance. It worked great. They used saving the constructor their own way so that they could call super and so forth and call the functions on super in the scope of the current instance. They did all sorts of things, but they really molded anything they wanted to, and they got it. They got the classical inheritance imperative style programming.
So you mentioned a circle. Let's draw that circle. I think that's...
Okay, so let's draw that circle. How big the circle is going to be here? Is that good?
Sure, yeah, that's perfect.
It's a lopsided egg.
And you're the artist.
And I'm the artist. So what do you mean by this? So we have...
So this here is JavaScript.
Okay, the language.
And as appropriately drawn here, it's a little lopsided. It has some jagged edges.
It's like some sharp, what do they call those things that are in caves that are really...
Stalactites?
Yes, they're really pokey. And they kill you if they fall.
Some punji sticks down here at the bottom.
There you go.
Boy,
So
this is...
be careful where you
Wild
tread.
West.
It is the Wild West.
If I could draw a cowboy hat, I'd draw a little Stetson here
There
on
you
top
go.
of...
Oh, there you go. Now it looks like Arby's. We're good.
So let's say I'm in, I come to work someday and I have a problem to solve, and I think, to solve this problem, I really need a dynamic imperative programming language.
Well, build it. Build the fence.
So let's see, dynamic and imperative, that's right here.
Okay.
We got that in JavaScript.
You do. Yeah. You can definitely enforce it yourself. You can make that subset and say, this is the realm that I'm living in.
Then it's up to me to use it that way.
Right.
Right.
It doesn't prevent you from ever stepping outside the bounds. I mean, if someone comes in and says, I'm just going to do it willy-nilly, whatever I want, JavaScript's not going to scream at them for doing that.
Okay, then I come to work the next day and say, this problem really demands a functional programming language with some static type enforcement.
Okay. So this basically, is this like what represents the static type enforcement?
Yeah, so I'm going to have to do a little extra work to make that happen.
Right.
But I get all of my functional programming and stuff in here.
So you're enforcing types and so forth, and you need, is this one imperative one that you said?
This one's imperative, this is functional.
Okay, so this is functional. So I've realized what's happened. The escape hatch in JavaScript is always open. As a matter of fact, it is the escape hatch.
That's a language full of escape hatches.
And what it does is, it gives you the ability to define your boundaries as a programmer. But this is where it bites a lot of beginners, because I love learning. I love learning JavaScript, and I love teaching JavaScript to people. But when they start doing heavy software engineering problems or handling those kind of problems, that's where it kind of bites you a little bit, because you expect it to be more structured.
Mm-hmm.
They don't expect to have to build the structure to then build on top of that.
So if you were teaching somebody programming, you could say, this is how you do procedural programming.
Right.
And you'll
Yeah.
use this part of JavaScript to teach them.
Yeah. You definitely could do that.
And then the next day you're going to say, we're going to talk about object-oriented programming. And you're going to use this part to do that.
Right.
And the next day we'll talk about prototypal inheritance. And you'll use this part
Right.
to do that. And then you might come across a project that doesn't fit squarely in any one of these paradigms. And you end up...
You know, a good one would be like, you said these two, would be like, you said procedural, right?
Mm-hmm.
And you said OOP here.
Uh-huh.
This is like the DOM land. Because, you know, like the script languages, there's always this procedural stuff.
Yeah, in browsers.
In browsers. And so that would be a perfect example of DOM land. It would probably encompass more, but yeah, essentially you can do anything you want. I remember when I had the, when I wanted to make queryables in JavaScript, learning them in C# and how do I implement these in JavaScript? I could do it. And it was absolutely amazing. I could even have built it even better to where like deep nest traversal, if I built another subset, you know, like how you said, like build a little more out here, called object mirrors. So I have like a reflection type system to where you can pass in a type and it would give you back a map of all the methods and properties and information about that stuff. So it's all possible in JavaScript. It's just how much of that boilerplate work do you want to really do, how much of that foundation you want to build, and how much of the JavaScript mess do you want to use.
So JavaScript is so versatile that people are even writing languages on top of it. Like
Yeah.
writing more languages in JavaScript.
You've got ASM now that compiles C code, C++ code down into JavaScript.
Now why would you compile something as efficient and pure as C into something like JavaScript?
Because it runs everywhere.
Everywhere?
Everywhere.
Run on my refrigerator?
Probably. Okay, maybe not there.
Not
but,
yet, but it'll happen.
Probably will. It's so ubiquitous that it's everywhere.
So like on my laptop I have Google Chrome and Internet Explorer and Firefox and Chrome Canary and Firefox Aurora.
So you got 7 or 6, how many?
I've got and Node.js, so I've got at least 6 JavaScript environments on that one computer.
What was it? I heard once someone said that even if you pulled out the first one of the IE5, it would have JavaScript in it. I mean, how far back can you go? And it has it in there. I mean, you're dealing with ECMAScript 3 or something like that. But the point is you've got it. And
it's on your phone.
It's everywhere. So this is why people are, you know, you write in this language of C and C++, and you want this to run in the browser, we'll just send it through the ASM compiler, and it turns out the code for JavaScript that's not legible at all, and it works in weird ways. But the fact is, it uses all sorts of things in JavaScript, its quirkiness, its dynamicness. And what I heard a person say, and I think this was in an interview with Eric Myers, and it was a Channel 9 show. They were talking about converting languages into JavaScript and how they did it. And they said, well, really, JavaScript's like an assembly language. Like an assembly, you can do basically anything you want to. Go to statements, go to here and burn and blow the whole thing up. Well, JavaScript's got all that for you. You can do all sorts of weird, crazy stuff and just write it all out. And they realized that it's kind of like an assembly language. And then what that did is I think it propelled a lot of other thoughts like ASM. I don't think Channel 9 did that to ASM, but what I mean is it just encourages. JavaScript encourages people to try it.
So we got ASM, TypeScript,
Dart,
Coffee, Dart.
Yeah.
And all of these are leveraging this weirdness that is JavaScript. I mean, we've been hearing talk lately of JavaScript becoming the new bytecode.
Right. Douglas Crockford talked about that, and he says, write your own language and...
Think about that for just a half a minute. JavaScript as the new bytecode. That blows my mind.
Oh, Brendan Eich also said that. He said, we're building JavaScript to not only be for the hardcore JavaScript engineers like we want to call ourselves, but also for the people that like ASM, where they want to compile a code of different languages into JavaScript. They're trying to hit the sweet spot. They want JavaScript to be this huge... They just want to get rid of either side.
So I guess the moral of the story here is JavaScript is not all rainbows and butterflies.
No.
There's some really ugly stuff in there.
But it can be.
But just because there's bad stuff There's a lot of good stuff, and there's a lot of weird stuff. But hopefully we've given you enough reasons to want to learn this language.
Right.
It's everywhere. You can get away with whatever you want. It does tend to put a little more pressure on you, the developer, to stick to one of these paradigms.
And it's the Wild West.
Because it's the Wild West, and if you end up going all over the place, you're going to end up with some really garbage software.
Right.
And that nobody will maintain. But if you can be well disciplined and know what's going on, you're going to write awesome programs that are perfectly maintainable and run everywhere. And that's pretty awesome.
That is.
It's not the perfect language, but there's like 7 perfect languages hiding inside.
But I would like to challenge even our viewers to come up with some kind of paradigm that's in another language, right? And we've only listed a few, like functional and imperative. And think of something. I don't know. Maybe there's something out there that I'm unaware of that we can't mimic in JavaScript.
There's one thing that we've run into in recent months, and it's being addressed in ECMA 7, I think. And that's operator overloading.
Yeah, that's true.
That's like the one thing. But with some goofy, half illegal tricks, you can even get around that.
Yeah, and you could also just make it, a function call versus having it just be so simple and beautiful with an operator.
Yeah, you instead of saying that, you just say add.
Add, and then you pass it, the two things. And this is how these languages like Dart and ASM and TypeScript can do these things, because you can say this, but they really mean this, and now you can translate it to anything you want. So
yeah.
In all reality, you can get around about anything.
So JavaScript is still awesome, and we think it's definitely worth learning.
And we still love it.
We still love it in spite of, it's like a human being, Nobody's perfect, but we can love them anyway. And on that really touchy-feely note,
we'll leave you to your YouTube channel.
love JavaScript. If you don't love it, at least learn it.
That's right.